Hey there, welcome back, TGIF everyone. Welcome to the Friday stream. Finally we made it till the end of the week. The weekend is upon us. And as usual, before we can have our rest, we have some shit to do. And yes, today we are going back to our PCB and KiCAD. I had some complaints last stream that KiCAD is a little bit retarded. Turns out the problem is not actually with KiCAD. I think it's more of a me issue. I was complaining that I can't remove the text tables from footprints, and that was obviously my mistake. As it turned out later, it's perfectly doable. The issue was that I was treating those footprints the same way I used to do it in EasyDA. And in EasyDA, the footprint and the title or the text that is attached to it and everything else, including even the nets, everything is in one properties tab. So if you open footprint in KiCAD and you press E, come on, okay, like this. So then you have everything to change. In KiCAD it's a little bit different from what I reckon. So for example, I can just select this text and I can make it not visible just from here. So I was complaining about these paths that I wasn't able to show the text. Oh, looks like you can just select all the text just from here, and then you can actually change the property. Yeah, so that is not that bad. It's not as retarded as I was complaining. What else? Well, other than that, nothing much really. But what I realized that I think we can do some upgrades to the schematic, because we don't really need this element and this element, because what they do, they will just give us these footprints. And we don't want this because everything will be soldered to those paths. So what we actually need is a little bit more paths instead of this photo transistor, if I get it correctly. So I think we can change that right now. And yeah, I think we can also change the volume encoder, because as you can see over here, the volume encoder is not really on the PCB. It's gonna be completely detached. So obviously this footprint won't really help us much. So instead, what we should do, we should remove it, and then all those nets that we have over here, we should attach to more paths, and then we can put those paths somewhere, maybe around here or maybe here, depending how much space we have. So then when we attach it over here to the plate, we can just route the wires, and this should give us like an easy way to connect this thing. Yeah, so I think that's it in terms of updates from the previous stream. Yeah, I was also looking at this part because over here we tend to have those two wires that are like 1 millimeter, and one is from, I mean both are for I2C. One should be for data and the other one was for the clock. So I know it's not gonna look nice when we have like wires sticking out, but I think I'm gonna add some paths to here, probably one here and one here, or maybe one here and the other one over here, so there will be more space. And most probably I'm gonna use those anyway, because you never know how many I2C devices you're gonna have, because like currently I'm saying, okay, I don't want a screen, but maybe when sometime later when I decide, okay, maybe we should try to add a screen to it, so then we will need some more I2C paths. So that would be a little bit difficult to foresee, like how many do we need. maybe 1, maybe 2, maybe 3 sets, and having those attached, so we can just connect wire, and then there'll be plenty of space to connect almost anything. So yeah, that is one additional thing that I was just thinking about. Yeah, and other than that, I think after we are done with those footprints, I'm going to be changing the schematic over here. I think we can finally start working more on the PCB. I don't think we'll be doing any more changes to the schematic. And I see that for some reason Twitch has not refreshed. Kind of odd, not sure what is happening. Every time I start streaming, I can see myself on Twitch. Yeah, anyways, it seems to be working now. Good to know that at least it's streaming to Twitch. Yeah, so I think that's it. That's the plan for today. Change the schematic, then we can jump onto the PCB. We can finally start placing all those elements. I also did one more update because for those connection diagrams that we have here, I've been struggling to look at it because they should have been mirrored. So this is what I done. Now they are like properly mirrored. So you have the left side, and the left side looks exactly how you're gonna be routing it. So it's easier to look at it, easier to orient yourself. And also for the left side, we don't have these two. So I have to remember, most of you will forget anyway, well that's fine. We have to remember that we should not connect these to anything. We should just leave those paths open. I'm not quite sure at this moment where I'm gonna put them. Most probably somewhere close to the I2C expander. I don't know if I'm gonna be using them since I didn't really like mouse keys being here. I prefer to have it like it used to be on the thumb. Maybe we can later on explore one more additional infrared. So I was thinking maybe we can add one infrared somewhere over here. So then this way, when I move my hand to the ball, this should trigger like the mouse layer. So then we can have those 3 keys. We can change to mouse buttons. And then when I move my hand away, when I go back and I try to type something, then it will just switch off, and then we will have letters over here again, like the base layer kind of. So that might be interesting. I had similar design some time ago on a different keyboard. That one didn't work, but the issue with it was that that keyboard had like a full, almost full alphabet. That was the 3I2C that I was using before. And I noticed that sometimes I would just hover my hand on the ball when I was doing something with the left side. So I could just type some letters with the left side and without even moving my hand from the ball. On Chordie, I don't think this scenario will happen because like most of the time, if I need to type anything, I need to have both hands on the keys. So, and I think I kind of realized that I don't really keep my hand on the ball that often. If I do anything with the cursor, if I want to click, then the hand is over the ball. But if I want to type something, then of course I have to move it. Even though I must be using even one hand, then I still will move my right hand. So this is something that we can explore. It should be easy to do. We should have plenty of possibilities, and with the PCB it shouldn't really take that much time. It's just a matter of connecting a couple of wires, and that should be fast and easy. I think I talked too much. Alright, so let's do this thing. So let's copy one more. Actually, we need two. We need two of those. Maybe removing the names over here wasn't that good. Okay, so I think we can remove that. And instead of this, okay, we won't be needing this ground anymore because we're gonna have it here either way. So these are two grounds. One is for the transistor and the other one will be for the diode. So it's gonna be almost the same as when hand wiring. Okay, I don't want to do a wire. Maybe I should just change to symbol. I'm not sure why it's doing like this. Okay, maybe let's go all items. Okay, so I'm gonna rotate like this and connect over here. So this one will go to I2C, so to B5 on the left side or on the left expander. So we got that set up right, but this one needs a little bit more. Okay, value footprint. It would be nice if you could just give it like a net. Can we set up net over here? Value. Okay, let's see if I hit. Okay, TP23. Okay, maybe we should change that to, let's do it TP, maybe left, and let's call it collector. I hope this will help. Okay, so this is the ground. Okay, so I think I need to, I can remove these as well. We're gonna be needing this power stuff. Where was it? Line. Oh yes, power flag. Let's drop it somewhere safe. How about we add it? Oh, let's add it over here. We won't be changing anything with our I2C expander, at least on the left side, so we can leave it like that. Alrighty, so we have this done. Yeah, I'm gonna leave the name like this, so at least I know what is what. And also for this one, for this one, let's call it TP left, and this one will be, and this will be anode. Oh, let's make it this. Okay, I forgot to show this. Okay. Oh yeah, right. So we need to remove this and this one, and from here okay, so instead of having a symbol for opto transistor, all we need is just a pin for the collector. So from this pin we will go to I2C, and then we will drop it. We will drop this pin over here, and then we have this pin for the anode, for the diode, and we're gonna drop it over here. And this technically should work. Okay, going back to our schematic, we still need to do something with this encoder. So, okay, let's copy. Okay, I'm gonna paste. Actually, we need 5. So yeah, so 1 will be our ground. This one will be our ground. Okay, we can give it a name. Let's say left. Let's make it volume. And okay, should we make like okay, should we really make it like that, or should we just leave it like a default name, because ground doesn't really matter that much. We don't really. Okay, I'm gonna skip that. This one is not that important, so I'm gonna leave it because it's gonna be ground either way. So the ground will be common. Okay. I think I'm gonna change the name either way. Oh, come on, select. Okay, let's make it left common. Okay, and I forgot to show it. Okay, so this one will be left common. This one will be what's the name? Okay, we have one more, so let's do it switch ground. All right, this one. So we have more stuff to address. So we have we have the common pin already. We have ground for the switch. Then we need to do the switch. So let's call it left volume switch. Maybe like this, SW. Okay, let's show the name. Alrighty, so what we are left with is this one. Let's call it left volume B2. And this one will be left volume, let's make it uppercase B1. Would like it to be visible. Okay, so now we can safely remove this one. We have all the outputs over here. I'm gonna delete this thing. We don't need those wires. Okay, let's do wires. I'm still getting used to KiCAD. Some things are very odd to me. I don't understand why it's why is it making a wire and why nothing gets selected. Okay, there were like two different shortcuts for moving. One was, I think, M, and the other one was F maybe, or G. Okay, is there something over here? A place. Let's see. Draw wires, draw buses. Don't see anything. Okay, let's see. Okay, M and G. Okay, so let's take a look. If I do G, why is it? Oh, that is so stupid. Did I say that it's not retarded? Okay, I don't want wires, I just want to move this thing. Okay, so let's do it like this. So we have a COM pin, so that will be our ground. Okay, so we have common pin. And then let's say okay, we have this one. Okay, let's connect these two. So we have left volume B2 and then this one as well. Which one is it? This one. Are those like wires? Okay, looks like those were wires. Okay, so we have those two parts connected right now. So we have the common pin that will go to the ground. Then we have one pin, one path that will go to the I2C expander, to the B2. And then we have one that will go to B1. Okay, then we also need this one. Okay, why can't it grab this label? It makes you wonder, the net is which part of this is it gonna be text? Doesn't look like it. Is it gonna be wire? It looks like it's is it a wire? Oh, maybe not quite. Okay, this doesn't work. Label. Is this gonna... Okay, so it's a label. Okay, let's rotate it a little, like so. So this pin will go to the ground as well. And this one we just connect to this net. So we have this net that is meant for the switch, and this will go to the input B0 on the expander. So I just attach pin that is volume switch. So we have a pad that is called left. Maybe I should change the name, although it's rather obvious it's volume. Oh, let's leave it. Okay, left volume com. Okay, I see that I have it like this. That will be better. Okay, so now I know this one is volume common, volume B2, volume B1. So I have proper nets over here. Then we have switch ground. And then we have switch which goes to the I2C expander. This one we don't need to change because those pins I would like to use the original from the footprint that I designed. So this will be an opportunity to check if this footprint even works. Yeah, so switch is not connected over here. And then we have only this common. B will be assigned to B4 and A will be assigned to B3. Okay, looks about right. Okay, I think we have everything done, at least on the schematic side. Let's take a look if there are any issues other than the one that we had before. Okay, item not annotate. Which one is it? Okay, right. So it needs a number like this. But that is odd because it's not complaining about this one. I wonder if it's gonna complain if I run it again. Yeah, so it looks like it requires a number after every label. That is not an issue. Let's see if it's gonna work now. Yeah, right. I forgot about these two. Like this, and this one should be 1 as well. Have I changed anything else that doesn't have a proper name? I don't think so. I think we are good. Maybe I should move this a little. Yeah, I know it doesn't look like a switch anymore. But I hope it will perform like one. Okay. Let's save it. Let's do one more check if there is anything that is not annotated yet. Okay, no issues. Cool. What was ignored? Okay, never mind. Since it's not complaining, it means it's okay. Okay, let's jump back to the schematic, and I think we should update. I mean, jump to the PCB, and we should update. Okay, what is the error here? Okay, it's complaining about what is this actually? Left resistor V1. Okay, we have those additional ones. It's odd that it didn't remove these. I think there's an option to. Okay, delete footprints with no symbols. Do we want that? No, we don't want that. Okay, remove footprint fields not found in symbols. This should do the trick, probably. Oh no, it didn't. That is odd because we don't have that anymore. Okay, one more try. Let's see what happens. It looks like it didn't really remove. I'm gonna do it myself. I'm not gonna dwell on it, why it's not removed yet. Okay, so far, so good. Okay, so we have switch. Okay, for the infrared anode, I think, let me take a look. Yeah, so the diode, the infrared diode is on the bottom. So I'm gonna drop it over here. Then we have collector, which is here. Can we align it somehow? Does it look nice? I think it's okay. I only hope it will be enough space to solder it. Okay, so yeah, looking at the keyboard right now, so I can see the diode, the blue thing over here, so that is the infrared. So this one is at the bottom, and then the collector is on top. So for the diode, I mean for this part, for the infrared, I think we are good. There's nothing more. Alright, so this one is our switch from the volume. Let's drop it here for now. And this one also goes to the volume, and this one also goes to the volume. There's quite a lot of them already. And of course we need a common pin as well. Okay, so I'm gonna adjust this later. For now I'm gonna drop it over here, and that's fine. Only after we do the switches, the paths for the switches, we can somehow align it. I remember when I was doing my PCB some time ago in EasyDA, I had the same issue that there was not enough space for all those paths here, so that was kind of tricky to get working. But that should be fine. It's gonna be a bit tricky to solder, because if we have yeah, we're gonna have them on top. But there are two options here. We can either do it like this, so we can have a surface mount. I mean, all those paths can be only on the surface, and that should be okay. The only issue is that it might be a little bit difficult to solder, because we're gonna have to like dig with the soldering iron. It's gonna be a bit abstract, not enough space, I suppose, because we have to go into the column of the switch. So for a very tall switch, that might be a little bit difficult. Okay, if we... It might make sense to do those through hole. Okay, shall we maybe do it? Well, okay. I don't think it's gonna work. We can't make this through hole. Like for the switches, if we make a through hole, so then on the other side, if we would be doing the right side, would it work? Because we're gonna connect to like different expanders, so that shouldn't matter. Oh, okay, maybe it will work. Okay, that's something to consider maybe later. First we need to have this stuff kind of laid out. Okay, so over here I have the connections for Chordie. So I can see that we have A0, A1, R2, and so forth. Okay, so what we have? Okay, this one is A0. So A0 goes... A0 goes here. Then we have A1. Where can I find it? It's here. I'm gonna drop it here. That's A1, A2. Okay, somehow I can't see it. Do we have it? Oh yeah, we do have it on the schematic. Okay, it's here. Kind of got lost. Okay, so A0, 1 and 2, so that is correct for the left side. Then we have A0, 1, A2, we have A3 over here. We have A3 over here. Okay, then we're gonna skip A5 and A4. Do we have them? Okay, we do have them somewhere. So I think I will put them somewhere close to the I2C expander. So maybe we can use them in the future. So A4 and A5. Where did I lose A5? Oh, it's here. Okay, cool. Let's move it over here. So where do we have enough space for that? Maybe just drop it over here for now. And we're gonna worry later how to orient all this stuff. Ah, yeah, right. There is still issue with the potentiometer. Okay, so this is what it was complaining about. So that's the one. We don't have a footprint for that because I haven't decided yet how I want to do it. Those SMD potentiometers that I have, they look kind of nice and would be okay to have them. But the issue is they are so tiny, it might be very difficult to solder. Then we have the ones that we've been using before. Of course, I don't have them anywhere. Ah, yeah, right, these. So we have these. I would call them standard Chordie potentiometers. But then there is an issue that we would need to make a cutout in the PCB to make it work. Okay. We're gonna worry about it maybe later. Let's route all of this stuff first. Maybe not route, but like just put everything in place, put layout, all of them. Okay, so A3 we have done already. Where is it? Okay, this one A3 is in the right position. A4 and 5 I have over here, so that is for later if we want to extend. Not sure what we can add more. Okay, A6. A6 is over here. So A6 goes here. Then we should have A7, right? Somewhere. B6, B7, A7. Okay. Okay, A7, then we have B7 and B6. And there is B6 over here. Okay, like this. Okay, one more quick check. So A0, A1, A2, and A3. Over here we have A4 and A5 we have here. And then we have A6, A7, B7, B6. Over here we have encoder, B4, 3, and no switch, B6. And over here we have B5 from the collector. Alrighty. So we have so many ground pins right now. So this will be together with the switches. Well, actually over here where the, okay. I was thinking that, oh, since we have a common pin and ground pin, it's gonna be the same. It's gonna be ground anyway. So I was thinking maybe we can just cut one path and that would be good. But then I remember that it's gonna be close to impossible to solder two wires to one path. So it's gonna be better to have two. So we're gonna have one ground for the encoder and the other ground for the switch. Well, actually it's gonna be even three, because there will be one ground for the common pin on the encoder. Then will be one ground for the switch from the encoder, from the volume, from the volume. And then will be one more for the switch for A6. So that's gonna be like 3 ground pins. So yeah, this that's why it was so cluttered down there. Okay, am I correct? One ground, second ground, third ground. Okay, that is fine. Okay, let's move this one. Okay, I have so many ground pins left. Okay, where is this one? Ah, okay, because, okay, I have A5. Okay, for A2 as well. Okay, this is gonna be for A4 and A5. Yeah, I was also thinking maybe we should still use the wire for the ground to attach everything to the ground wire, just like we had in the hand wiring. Although, yeah, I think the pins will be more neat, nicer to use, cleaner definitely, than moving all the wires to this one thick wire that we used to use on the hand-wired version. Okay, so everything is more or less done. Okay, I think I can remove from... Ah, yeah, right. So we don't really have this one anymore. So I can remove this footprint. We have only one encoder. Okay, let's tidy up a little. This should give us enough space. Okay, this one I'm gonna leave for later, for dessert. If I double click, okay, I get the settings for it. More or less. It doesn't have to be super precise. We don't really care that much. Okay, over here we have everything done correctly. This one we can't really change anything. This one will remain normal. They don't look like they're on the same X and Y coordinates. Can I X and Y? Okay, Y is the same. Okay, they kind of look like they are not on the same position, but looks like they are. Okay, so we have those extra pins from here. Everything else is occupied on this side. Let's move all of this stuff a little bit down. Okay, so the bottom was VCC, right? So maybe we could just add... Was it VCC? Yes, I think it was VCC. Yeah, it might come handy. I'm gonna add one more pin over here. Yeah, and over there as well. But this one I would like to change. Okay, so it's not like this. Can I edit the net? Yes, I can edit over here. That is cool. So this one will be 5 volts. Because we have a wire over here. We can attach a wire. This might come handy because, as I said, I don't really know how many different things I will connect in the future. So I think it's good to have a rail over here. And I also would like to have 2 paths. Maybe I will do one over here and one somewhere here. Or like so. So this one will be the same as... Okay, this one will be... okay, let's change this to data. This one will be data. And this one will be clock. The net for the clock. It says it's this... it's the net from the resistor, but in fact all of them, they kind of connect to one point, so it doesn't really matter what it say. This should work either way. I hope it will work. We're gonna find out when the PCB finally arrives. Okay, I can see there's a lot of mess over here. Okay, so we have our standard switch and the ground for it. Let's move this one up. Okay, B1 and B2. Okay, so let's do it like this. B2 over here, B1. So this will be ground. That is common pin. So let's drop it over here. This one will be for the switch. So B2, B1. Okay, I'm gonna do it like this, since they are all together. So it will be B2, B1, and the ground. And over here we have one more switch. That will be the mute switch from the volume. Maybe a little bit higher up. Okay, does it look okay? Does it make sense? So we have A6 and ground, so that is our switch that will be coming from the column. Then over here we have a canal, so we can route the wires, right? So we have ground over here, and this one will go to the encoder, this one will go to the encoder as well, and this one as well. So B1 and B2, actually these are from the encoder and the ground for it, so the common pin, and this one will be our switch that is used for the mute. Okay, looks more or less okay. Okay, we have this stuff over here, this stuff over here. Okay, we have clock on this side, we have SDA on data on this side. So yeah, just like before, we can have those like 2 extra wires here. This might come handy. Okay. This one is fine. Okay, 5 volts, because we're gonna have a wire here as well, just in case. Just in case. Okay, I forgot about one more thing, because we need a jack, a TRRS jack. So it would be nice to have it somewhere, have some extra pins. Maybe we can drop it over here. Let's take a look at our... Okay, so I think the TRRS will be over here, because we have this one closed already. Let's take a look. Let's do extensions. Left side will be the volume. Okay, yeah. So just as I said. Okay, but on the other hand, I said I would like to move them. But does it really make sense to keep it like this? Or maybe we should just drop them somewhere close to the I2C and then just wire. Because I was thinking maybe once it's done and it's working, maybe we can move this plug, maybe we can move it over here. It might make more sense. Although it's not that bad right now, but definitely what we will have to do, we have to make it lower, because it's taking out too much. And if we go on a very low profile version that I wanted to make for the choke switches, then it will be, most probably it will be colliding with the keycap, so it will be difficult to press. Yeah, it might be even worse if I ever want to do like super flat version. That will be, all of the keys will be on the same level. Although, like from the experience, what I done before, I think that having all of them flat is not really that great. It's better to have the thumb a little bit higher. It's easier to press. Well, unless we can get the infrared for the mouse keys working, then this will be better. Then we won't be using thumb that much. We'll be just operating with the fingers over here. Okay, so many things. Yeah, but anyways, I think it would be better to just drop it somewhere over here. Okay, so the issue is over here we have to come up with solution for the potentiometer. Well, on one hand, I would like to have those big encoders because they're easy to solder, easy to rotate, kind of nice. Okay, but let's take a look. Oh yeah, right, so we have anode over here, but we don't have this one yet. Well, technically we should also remove this and swap it with just two different pads. So one pad will be going from this resistor. So we will have one pad over here and then one more pad over here that will go to the anode, because we just need two pads. Let's take a look over here. Let's get rid of the PCB for a second. What I would like to see is the... Oh yeah, right. I think we can orient this. Okay, so it's 7.15 and from here it's 445. Makes me wonder, let's say we want to... Okay, we can't make a round opening. I think we're gonna need a little bit more space here. So there are a few things that we need to address. First thing is that we need to have a hole that will fit the whole body of the potentiometer. Then we need some extra space so we can slide it in. And then we need two pads. One pad will be over here and one will be in the center. So this way we can solder it. So it's gonna look something like this. Take a look. Like we have this one. Do I have a PCB somewhere? Oh yeah, I have. I think I already showed that before on a previous stream. Okay, not this one. Yeah, something like this. So let's say this is our PCB. This is where the encoder should be. So we can attach it like this. So then one leg will be on top, on the top layer, and the middle leg, that is the actual output, will be over here on the bottom. Yeah, so it will be something like this. So if you want to slide it, so we're gonna be needing a little bit more space. Yeah, although we can always like chop off the legs anyway, like those things that are sticking out. We can make it really short and then it should be no problem. And makes me wonder, so then if we flip the board around, so it should be on a different location completely and should be swapped like this. Okay, so I think we can do it like that. It's very tricky. I'm not that much confident in KiCAD yet. Like in EasyEDA, that would be no problem for me. Also, but I have a lot more experience with EasyEDA. Okay, I guess we have to learn somehow. My first PCB from EasyEDA was also broken, and I found out before it even arrived. So yeah, this is how it goes. First PCB is always broken. Alright, so what is the size of this thing? Okay, so it's 650. And over here it's 7. Alright, so let's take a look over here. Where are we? Let's remove the bottom. What is the size of this? 655. Okay, so I made it a little bit tight, but it fits. It fits okay. So I think we can do it like this. Okay, this one's obviously longer. One more measurement. And maybe we should take a look at the datasheet for this thing. I think it's 0.65. Yeah. Okay, not this one. 63. Okay. We even have we have dimensions already. Okay. Is there like a data sheet? Oh, yes. Okay, it says it's 6.4. And this is 7.8. Okay, so I think we can do it like that. Righty, so let's jump here. So how can we approach that? Let's see. If we do like a rectangle, can we measure it somehow? Ah, yes. Okay. Center and size. Okay. This makes sense. So let's make it 7.8. Let's make it 7.9. Let's give it some more space. Although this should be actually Y. So let's make it 655 by 7.9. And this will be edge cut. Let's make it fill shape. Okay. Okay, let's say it's all right. So then we need one more. We need actually two more paths. So one path should be one path should be over here for one leg, and the other one should be in the center, but on the other side of the board. Also makes me wonder, okay. So we're gonna have it like this. This will be our PCB. And it's gonna be sitting like this. Okay, so actually the center one should be on top. And then this one should be on the bottom of the PCB. Yeah, I think. Okay, but no, 1 second. Well, either way, it's gonna be sitting like this. Okay, because we have opening like so. Yeah, I think I have a bottom somewhere. Yep. Okay. So it needs to sit like this. So then PCB will be over here. Something like this. So, okay, so I was right. So the center part should be on top of the PCB. And then the other one should be at the bottom. Either the bottom one or top one. It doesn't really matter because the potentiometer, like the output is one of the side ones, and then we go through the middle one. Okay. Good to have something to rely on, to check what is happening. Okay, so we have this opening right here. It makes me wonder, so if we make it too small, it might be a little bit difficult to properly align. But we made it bigger, so shouldn't be an issue. Let's take a look where actually is the center. Oh, okay. I think we can align the center of the cutout to what we have on the bottom. So this one says it's 715. So if I do it like this, and I should be able to position it like this to this one. Okay, I think I did it wrong. Okay, I want this element position. Let's do it interactively. Okay, so center from this to center to this, and offset should be 7.15. in X, and Y is 445. 445, 5, like this. Okay. So now it should be okay. I can see that it's kind of going around. And maybe we should make it a little bit bigger just to be on the safe side. Let's make it 8 point, maybe 2. Okay, if I make it too big, would it be still possible to align? Okay, I'm gonna leave it as it is. Let's leave it at 7.9. Although it looks kind of odd to me. But like we know that the edge is over here. Okay, I'm gonna make it bigger. I'm gonna make it 8.2 just to be safe. Because like when we will be mounting it, it should still, I think it should hold on this side either way. Even if the board is cut a little bit larger, right? So still we will have on top, there will be the top, like the top layer of the keyboard. So this will help us align. Okay, should be good. Just give it some more space. That will be enough to like attach it. Okay, so let's see, what do we have over here? Can I make a pad? I think I can just add footprint. I think there are like a lot of test points. Let's make a square one. What is the size of this actually? Maybe we don't have to go too crazy with the size. 1.8, so like 2 millimeters should be okay. We have 2 by 2. We have round ones. Bridges, nothing interesting. We have through hole. That doesn't really interest us. Okay, so 2 by 2 is a little bit too much. It will be okay. Let's take a look. Maybe it will be okay. Should be good. So we put one over here. And I think I copied the wrong thing. Okay, Ctrl C and Okay, but this one goes. Okay, this one is FCU. So this one is correct, and this one should go on the bottom. I guess they can overlap a little. It doesn't really matter because they are not on the same plane. We don't want this, we don't want this. Okay, let's hide all of that. Okay, so for this one, we have to set up a net. So let's do it like this. Just the path, and the net will be to the anode. Where is it? Okay, I think that's the one. Yes, so over here, so I called it RV1. That's kind of not a good name. It should be something more related to... I think I'm gonna change the name. It's kind of misleading. This should be left. Let's do it potentiometer, anode, make it 1, like this. Yeah, okay, as I said, I think we can remove that. Okay, let's get rid of this thing. We don't need that. What we need is... we need more pads. God damn it. Okay, this should do the trick. Oh, come on. Okay, the name doesn't really matter. 23. Okay, so this one will be... one needs to go to the resistor, then to anode. Okay, so let's make it... that's gonna be left. Let's call it potentiometer in 1. Would be nice to have it shown. Can I move it? So like this, and this one will be kind of like an output from the potentiometer. call it L, bot out 1, make it visible, so less confusion maybe if I leave it like that. Yeah, so we kind of removed the potentiometer that we had before. So now from this resistor that is supposed to limit the current when, let's say, we go with the potentiometer all the way to 0, so 68 should be enough to prevent the diode from burning. And then with the potentiometer we can kind of adjust how sensitive infrared will be. So that is okay, and then kind of like an output from the potentiometer will be this pad. Yeah, so that should do the trick. Okay, let's update. Okay, so we have those 2 points over here. Okay, I think I'm gonna drop it. Yeah, the footprint. We need to change the footprint. I mean, it doesn't really matter that much, but we can do it on the PCB. I think I have used this one, 2x2. So this one and this one is also two by two. And so now if I update this, it should change. Yeah. Okay, so we can get rid of these. We put one over here, the other one a little bit lower, and it has to go on the different layer. Ah, we have it over here. So this one goes to the bottom. We don't need all this text on it. And this one also. Okay, so from here we have a rod net to this one. Okay, I'm gonna change them. I'm gonna change them because it will be easier to route. So this one goes to the top. And this one goes to the bottom. Why is it showing the name? Okay, what is it now? I would like to have this text removed. Okay, it's still there. Anyways. Okay, but this is on the bottom. Okay, is this everything? That is a good question. So let's take a look. We have all the switches done over here. We have infrared done as well. So we have a diode on the bottom, then we have a collector over here. And this is gonna connect to B5 to VCC. One more thing. Okay, this resistor. Okay, I think it's done correctly. The collector B5, yeah, should be okay. So okay, over here we have this resistor. This is a capacitor, like filtering one. So we can put all those resistors close together. Okay, this is capacitor as well. Is it? No, kind of odd. Why is it different? B5. So B5 is, it's a resistor as well. This is capacitor, this is resistor. These are resistors as well. Okay, the question is 0805, so it's the same footprint. Why is this one different? Hand soldered. And this one is not hand soldered? Okay, it's the same. They kind of look different. Okay, now it's fine. Let's rotate this like so. I'll be right back. Okay. What is this one? this one is also, this one goes, okay, this one goes to here. It doesn't really matter, we can also leave it on top because we can do it like this. We can route to be 5 volts. Okay, this one needs to be rotated, so we can connect to here, and then we can move from here to VCC, for example. So VCC will go through here. It doesn't matter like how is this set, if it's like 0 or 1K. But then it will go through here, through this resistor. So this is a little bit convoluted right now. Okay, switches, this encoder is done as well, the volume one. So we have a switch over here, and encoder stuff is here. Let's maybe get rid of the text. Okay, so the last one is the mute switch from the volume encoder. Okay, over here we have switch, we have extra pad for I2C. This one's for the clock, this one is for data. Okay, we have ground, this one is B7. I think it's correct, yeah. B7 and B6 over here. And what else? This one is our infrared. Should be okay. Okay, looks like we have everything laid out. I am a little bit worried about this opening for the encoder. Okay, let's take a look one more time on the keyboard. So we have all the switches. We have those two extra pinned out. We have volume, up, down, we have mute. We have encoder at the bottom. We have infrared as well over here. So I2C expander, we have extra voltage on the bottom. Okay, so it looks like we have everything. This is pull up for the okay, this is pull up for the interrupt, so that is okay as well. We have a filtering capacitor over here and those like standard resistors. Alrighty, so I think it should be more or less okay. Let's take a look. If we do 3D, what does it look like? Okay, so we have all those paths. Should we put any names? all the cutouts. We have cutout here. We have this pad over here for the potentiometer. We have pad over here for potentiometer. I only hope that we can fit in the potentiometer right here. Well, technically, looking at it, okay, I can't move those things like that. Well, we have center aligned anyway. It kind of worries me that it's so far behind. Let's do a wire from and do a wire. I just wanted to see if it's possible to about line. Okay, that is 7.5, and the size was what? Looks like there's plenty of space. So hopefully it will fit. No problem. Okay, so I think we can start routing all this stuff. At least for this part. It will get a little bit more tricky when we get to the right side. Okay. So for the ground, we don't really have to do anything because we can make, I think it's called copper pour or something like that. Okay, field zones, I think that's the name over here. So we can just like select a zone. So we can just select the whole PCB and we can set net, which one we want it to be. So we can set like a ground, and this will connect this will be like a ground plane, I think it's called. So this will automatically connect all of the ground pads for us everywhere. So we don't have to worry about that. Okay, this one. Okay, so let's start routing. So this is our 5 volts. We can... Okay, where did it go? It's transparent, yeah. Okay, something is off. Something new. Okay, why can't I see? Okay, I think I am on the wrong plane. I think it should be... Should it be solder mask? Oh no, I don't think so. Okay, maybe... What do we have over here? Okay. Let's try now. Yeah, that's kind of odd. Why is it transparent? Something new. Yeah, I see there's a lot of stuff. Yeah, that is kind of odd. I'm pretty much sure there's some setting. Yeah, so the thing that I had the issue before was the text. Yeah, I think we can switch out the fab. Okay, so let's go back to the wire. Why is it transparent? Oh, okay. Not sure what that was. Sketch tracks, show tracks in outline mode. Anyways, it's back. I can see it. Okay, so 5 volts. Let's connect all of them. This is ground. What else do we have? Okay, let's connect this one to this. What is it now? Okay, so this is 5 volts, SDA. We have clock. Ground we don't have to touch. Okay, B5 goes to here. What else do we have? So we need to make a via over here. And we have to jump to the bottom. All right, so to here. Okay, now we have to route this one somehow. Can we arrange it a little bit like nicer somehow? Would be nice if we could do both of them. B7, B5 is here as well. I don't think we can fit both wires. Most probably it's gonna be an issue if we do DRC. Oh my god, that's a lot. Okay. Okay, so most of the stuff is... what's wrong with this one? So something wrong with the via. I was more worried about this one. It looks like we can fit. Okay, let's continue. Can we edit this somehow? Okay, how can I delete a piece of the track? Okay, this is a curve, but we don't need that. How can I edit this thing? That is interesting. That looks like yet another annoyance from KiCAD. Okay, I wasn't selecting. I need to select wire track. Okay, this part. Oh yeah, cool. I can remove that right now. Okay, let's continue. Okay, so we have it like this, and then we're gonna have an issue because if you want to get there, I think it would be okay to go like this. I don't know what's wrong with the via over here. Why is it complaining? Alright, can I change something over here? Position net, diameter 0.6. What's the problem? Okay, it says it's 0.15. 6. So does it mean that the hole is too small? Let's take a look at the DRC. Maybe we didn't really set up properly. Okay, we are here. Minimum via diameter is 25. So we have hole 0.3, so that is okay. Minimum annular width. What is that actually? It says 0.45. Have I saved the capabilities of JLC PCB? Most probably I haven't. JLC PCB paper. Alright. I don't want notifications. Okay, let's go specs. Okay, that's not it. Okay, this one. Do they say anything about the VIA? Alright, okay, so minimum is 0.15. I think that's the... Okay, minimum drill diameter for 2 or more layer PCB is 0.15. Okay, more costly. Alright, so we have 2 layer or 1 layer. I think it's 2 layers. Okay, 0.15 and 6.3. Okay, so I think minimum diameter is 0.15. Or is this should it be like this? Minimum via diameter. Okay, looks like the minimum drill diameter for 2 or more is 0.15. Or is this the annular, or what is that? Okay, let's leave it like that. Let's leave it 0.15, 0.15. Okay, we have only warnings about some text, so that is fine. Okay, let's continue routing. Can we go like this? I think this should be okay. Not to mention, I have no idea what I'm doing right now. I'm not a professional PCB designer, so this is all just trying to figure out as I go. Oh, such board is not that much complicated, so I think we should be good. Okay, A0. Okay, now it makes me wonder, so maybe it would be better to just move this stuff a little bit to the right, for example. So then if we are doing the other side, the right side, so I can shift the expander and everything more to the left side. So I will have more space to do any kind of vias and stuff, because if I leave it like that, so I have a I2C expander over here, and then I put another one on the bottom, it would be most probably impossible to route it. Most probably there would be not enough space. Like if I make a via somewhere, then it will be colliding with whatever is on the bottom. If I move it like to here, and then the bottom we can do like in reverse. I will have more freedom when I try to route anything. Okay, didn't really figure out that it's on the bottom. Oh, that is fine. I see it's kind of got a bit messy. Oh, come on. Okay. Let's try to route it somehow. Okay, so this one goes to the other side. But maybe it would make more sense to have it flipped around. Although we can do it like this, maybe we can go, if we try to do, where is A0? We go from here. Or maybe better this way. Let's make a via. Drop to the bottom. Okay, let's think about it. So from here we have to route it all the way to here. So this A0, A1. We can think about stacking it somehow. So if I route it here, then another one. Okay, let's see. I never liked routing. Ah, yeah, right, this is not... Okay. Oh, maybe it won't be that bad. Let's see. I'm gonna leave it over here for now. Let's do this one. Okay, we have 1, 2. I hope we can make it nice and tidy. It's better to avoid sharp angles. Like, I mean, 90 degrees. I will try to route it to here and then we can see what we can do about it. Okay, so we have A3. Alright, so A4 and A5 are over here, so this should be easy to route. Let's go like this. This is a little bit tight. I mean, I think it's okay. Oh yeah, right. Let's route first this one. We can either do via over here, but maybe instead of that, maybe we can do it like this. I have to get rid of this wire. Is there a shortcut for wire? Ah, it's X. I connect like this. And now maybe we can have this one. Most probably it's gonna backfire because I would like to most probably sometime later have something over here and I will have to redo the whole thing. Okay, but for now, let's say it's fine. Okay, we have a lot of wires coming from here. It looks like it was easier to hand wire than make a PCB for this. Oh yeah, I forgot about the mini jack. Okay, shall we make well, we do have a extension over here and here, so it should be okay. But maybe we should do it over here as well. Add some more from what I was looking at. Yeah, okay, I was saying that most probably we're gonna skip it. This is left side, so we don't really need. If it was the right side where the MCU is, then maybe we could think about it. But on the left side, Okay, I think we can go with the wires. Should be good enough. Where is A3? Okay, it's here. So it was 0, 1, 2. This is 3, 4, 5. Okay, where is A6 right now? It's here. But A6 will be even lower. Okay, so I think for A6 we should do like this, maybe do a via and then jump to the bottom. Are we too close? Okay, looks like it was too close. Okay, so we have A6. And okay, let's do A7. I hope that is good enough for via. What is the shortcut for via? Or Ctrl-Shift-X? I'll be more happy with just V. Can I move via together with the track? Apparently not. It makes me wonder if it's really gonna connect. What is wrong? Yeah, looks like not so much. Oh, hi there, Desperate Lotus. Well, it depends on the PCB. I don't like hand wiring, like in general. I always prefer to make a PCB. But routing for PCB is usually more difficult than routing just the wires. Wires, you are more flexible, don't really have to deal with anything. Just like when we are doing Chordie, you can just, route the wires however you want them, as long as they reach the path or whatever they are meant to. If you're making PCB, it's always an issue because, the vias are too close, then the tracks are too close, then like some tracks you have to, like over here, so we have to connect tracks like A7, A6 and so forth, but the order they will be coming in will be like reversed, so then we have to do some swapping. I mean, now I'm trying to do it like beforehand, but sometimes it happens that you route all the keys to the MCU, and then they are like all in reverse, like the pins on the MCU, let's say you have a A7 on top, and A7 should connect to the pin that is on the bottom of the MCU, and then you have to do some mumbo jumbo to correct. Yeah, I'm intending to do this as a reversible, so then should be cheaper and easier to manufacture, but then it's more difficult to route it because I had to move the expander to this side because the reversed one will be over here, so I don't really want to have an issue when I'm routing. So if I have a via over here and then I would have this expander underneath another one, so then it would be very difficult to route everything. So I hope moving this like that will help. Yeah, but the idea is to have a reversible PCB. So one PCB and you get two halves. Yeah, what I'm struggling with now, I find it a little bit odd. For example, this one, I would like to have it, yeah. So we can either remove the whole track, and now if I would like to route it, let's say I'm here, I would like to route it to here. Okay, now it works. Let's say I would like to do the bottom. Okay, bottom works as well. Okay, let's say if I would like to move this via... Okay, it allowed me. That is definitely too close. So let's do wire. Yeah, so it won't, now it won't let me connect. It would be nice if it could tell me before I put the via that it's too close. Maybe there's a setting somewhere, I don't really know. EasyEDA used to do it automatically. It would tell you that, oh, this via is too close to the track. So I think it has a bit better DRC checking. Over here, I think I have to do DRC right now. Wrong button. Where's DRC? This one. Yeah. So if I run the DRC, okay, we have warnings. Yeah, over here we have an error. Yeah, and now it says that's clearance violation. Yeah, and EasyEDA would tell me when I was routing it either way. So that is a little bit annoying. Maybe I'm doing it wrong. Yeah, also, can I edit? Can I edit this one? Would be nice if I could just do... If there was a handle, so I can just move only one part of this track. Looks like it's not. So it looks like I have to remove the whole track. Kind of odd. Yeah, but as I said, these are my first steps in KiCAD. Definitely I'm missing something, just like with the text and all this stuff. So I get to learn something. Okay, why it's not connecting? I have this via over here. Okay, because it's a different net mask. Okay, so I would like to change that to A7. Okay. All right. And now if I do DRC, okay, let's not focus on warnings. Okay, we have 37 errors, but these are unconnected, but violations. Okay, this one is too close. And this looks a little bit far to my liking. I think we can do it better. I mean, I think JLC should be able to make it like closer to the track. Let's take a look. And the board specs. Okay, minimum clearance. Is there something about via clearance over here? Okay, hole-to-hole clearance. No, that doesn't bother us. Oh yeah, this one, copper to hole clearance. Okay, let's take a look on JIC PCB. Okay, minimum via size diameter 0.15. Okay, so we got this right. Okay, but it doesn't specify the hole size. Okay, anyways. Okay, via hole to hole 0.2. So I guess it's gonna be 0.2. Yeah, so JLC has a little bit more detail. You have a hole to hole spacing, all this kind of stuff. It's not over here. Okay, let's take a look right now. Is there any difference? Okay, now we have no error anymore. So now it's not too close. Okay, let's say that it's okay. Fine with me. Yeah, so I'm trying to route all of these because this one was A7. So this one goes to here. So we have like from the top. I think I'll be going like this. This one is A0. So this one should go somewhere over here. Okay, this one. Okay, so I have to route it a little bit further away. Yeah, but more or less they will be going like this. Okay, I think I have all of them. A0, 1, 2, 3, 4, 5 is done already. 6 and 7. Or I just messed up. This one is what? This one is A0. Okay, so is it wrong? Yeah, it should be in reverse. So that's what I was talking about. Like now I have A7. This one should connect to here. But then I have another one that should connect over here. But like if I make a track like this, let's say, so then I will lock out. I can't make a track to here anymore. But that is not that much of a problem because we can do vias over here, and then we can kind of solve the issue. It would be nice if it could tell me that these vias are like too close. It's not complaining. Let's see what happens. Connect to this one. Okay. So we have to select a net for this one. So this one will be A7. Ah, no, this one should be A0, right? Okay, my bad. Okay, this one is A0. This one is what? What's the name? Okay, A1. And then we have A2. This one is A3. 4 and 5 are on the bottom already. This one is 6. And this one is 7. Okay, if I try to route it, I wonder if I will be getting any violations. Let's don't like it like that. All right, let's see. Okay, no violations. I'm surprised. I'm surprised that it's not complaining. Yes, now I have these. So, for example, from here, I can go to the bottom part, and I can route it like this. Of course, I should move it a little bit further away. Okay, so this one is a little bit wrong. Let's do via. Okay, we have some track left over here. Alrighty, so let's do it maybe a little bit further away. So this will be A0, A1, A2 and A3. A4 and 5 we have done. Let's see, 6 and 7. Okay, so let's jump back to the top layer. All right, we still have to set the vias. I mean, not the vias, we need to set the net for it. So this one will be A7, this one will be A6. What else? This one is A3. Alrighty. What else do we have? A3, A2, A1, and A0. Okay, so now I can try to route it. Okay, we are on top. I wonder if there are any errors. Okay, nothing. I wonder if makes you wonder if there is a feature in KiCAD to have a DRC check live whenever I do something. Okay, anyways, so let's do it. We go from here. Okay, I want to go bottom. Like this. Like this. Like this. I think this one was not really necessary. Okay, doesn't look that bad. Let's do a check. Okay, so we have some parts already wired. What do we have else left? Okay, PCB, so we have encoder 1, 2, 3, 4. Okay, so this part wasn't that bad. But now we have over here B1, B0. So do we have any other A's to connect? No, I think that's it. From A0 all the way to A7, everything is done. Okay, 4, 5. These are very close. Okay, so all right. So I think we can finish on this. We can continue with the port B, with the B side on Monday. And there we have some other stuff to connect as well, I2C and so forth. Okay, yeah, still plenty of work. Yeah, so doing PCB, I mean, it's more difficult in the beginning, like you have to wire all this stuff. But then it pays off, because if you want to solder something, if you're soldering the keyboard, PCB is so easy to solder compared to like wiring. It took us, I know, 6 hours, maybe even more, to hand wire Chordie with the PCB. I think we can do it in maybe 1 hour or maybe even less. Should be fast and easy. So yeah, initially it takes some time to do all the wires, to do all the tracks properly. But then when you're done with it, it's actually better, assuming it works, of course, because we've made so much mess. I hope everything is correct. Okay, anyways, let's finish on this one. Was kind of okay. I'm really happy how it's getting along. We still have some connections to make. Yeah, but it shouldn't be that bad. So we can continue on Monday. I really hope we can finish by the end of next week. So then I can order it, and maybe the week after it should arrive, so we can do some soldering and check if this contraption works in real life or not. Okay, other than that, I think that's it in terms of keyboard building. Have a great weekend ahead, have plenty of rest, come back on Monday fully rested and ready to do some more wiring and listening to my rambling about how stupid KiCAD is, only just to figure out later that it's actually not the KiCAD that is problematic here. Okay, anyways, enjoy your weekend, have plenty of rest, play games, go out, touch grass, and I see you all on Monday. Thanks for watching.